Hello, I'm Jeremiah. I'm in the machine tool technology course here at Horry Georgetown Technical College. I'm pursuing a machining career, taking blank pieces of metal and turning them into useful metal objects. With an associate's degree, a person can find positions such as machinist, tap and die maker, mold maker, or programmer for the computer controlled machines. We get the metal that we use from suppliers who get this from mills, which take raw material such as ore, melt it down, pull the specific type of metal out that is ore for, mix it with other metals and maybe carbon in the case of iron to make steel, to make a metal with specific characteristics, and we use these metals to make specific things. I will be using different tools to accomplish what I'm doing. The main tools that I will be using are machine tools. Machine tools are lathes and mills, and their cousins, the computer controlled lathe and mills. Lathes operate by turning work or part against a cutting tool to remove excessive material to form the part. A mill works a little different in as it rotates a cutting tool against a part to remove the excessive material to form the part. The programming that we do for the computer controlled machines is based off of the Cartesian coordinate system. Think of the little graph that you had to draw in math class, maybe pre-algebra, algebra, where you had to go x of 2, y of 3, or x of negative 3, y of 1. We use the same graphing system to locate our parts and know where to cut. We also use a program to draw, a computer-aided drafting program. We use specifically Mastercam in our class. There are several others. Mastercam you can use to make prints for manual machining, and these prints would have the way the part looks, 1 to 3 views so that you can see how it looks. It would have the dimensions, length, width, height, spacing for holes, spacing for little cutouts, all the information you need to know where to make a cut. This program, you can also draw a specific item and have it create a code for you to send to the computer controlled programs or machines. Depending on how you want to have it set up, it can either generate a generic code that a programmer that is familiar with the code can go in and edit it for a specific machine, because each machine has its own little quirks and needs. Or you can have it where if you're using just one type of machine or one brand of machine, it'll give you a specific program for just that machine. So you have several different options when using this programming. We also need to use very accurate measuring tools. On the left is a dial caliper, and on the right is a micrometer. A dial caliper will measure to 3 points beyond the decimal. A micrometer will measure to 4 spots beyond the decimal. Both of these are accurate enough to be able to give you a measurement on a sheet of paper on how thick it is. A normal piece of paper, such as notebook paper or printer paper, you're going to get a measurement between 3 and 4 thousandths thick. That is 0.003 to 0.004, somewhere in that range. With the skills that we learn, we will be able to work in a wide variety of spots. One of the examples here is a job shop. Job shops generally make low production per volume, like they might make 1, 3, 2, 8, 10 of a specific part that's only needed in low quantities. Maybe custom parts for a motorcycle, maybe gears for a specific clock that's only going to have limited numbers, just whatever, or even something for repairs where somebody only needs a small amount because he's not building new, he's repairing something. A machinist in this environment is going to have something new and different to do somewhere between daily to weekly to every couple of months, just depending on how many of an item is needed out of the production. The next place that I'm going to use as an example is Boeing. Boeing has different plants and subcontractors that make things for them all over the world. They also have a plant here in Charleston, South Carolina. This plant makes the after tail section for the plane. They also have a machine shop that works making parts for the aft section. They also make parts to assemble the planes once they get all the parts together. They have custom parts they need to do for the wiring harnesses for the wires and all the different parts in assembling. I'd also imagine that my next example might shock a few of you. I'd also imagine that you're probably familiar with the company that I'm going to use, which is Tupperware. Tupperware actually hires machinists to make molds for their products. Most of you are probably familiar with their products, such as their cake forms or their jello forms or their containers to put your leftover food in, take it to work with you. But you probably didn't realize that a machinist had to make a mold to make these items, had to be able to cut it to the correct shape and size, and then take and buff it and polish it to give a good finish on the plastic and make it look and operate and form as it's supposed to. There are also some basic requirements that you will need to be a good machinist, which you will be able to learn in associate's degree here at Tech. Now, math skills are important. We do have a couple of math classes here as part of our course. Addition, subtraction, basic algebra, being able to use fractions and decimals, a little bit of trig for triangulation. Also, problem solving skills are important. Being able to find a problem and figure out a solution. Planning the attack, basically sitting there, taking in all the information at the beginning and figuring out what you're going to do before you do it so that you can complete it correctly. A lot of people don't like to hear this, but in machining, you need to realize there's normally more than one correct way to do just about everything. Could be 2, could be 20, and they could all be fairly close in accuracy, which is another important thing, efficiency and accuracy. Setups are important too because you're only as good as you set up. You have to be able to take your part and put it, set it up correctly to be able to be machined. You also have to check at several intervals and measure to make sure you're doing everything correctly. You also need to be able to use some hand tools, wrenches, Allen wrenches, files, that sort of thing, tape measure. Right here shows what some mean salaries are. Mean salaries are middle of the road. It goes higher, it goes lower. Different jobs like the aerospace, which would be Boeing, pays a pretty good wage. Metal working machineries, 48,000. Other fabricating metal product manufacturing, 45,000 a year. You can make good money with this. The map on the right shows that pretty much all the U.S. has machining jobs available. South Carolina is in the second string, according to this map, but it's going to get better because we have Boeing here now. PTR has just come to the area, which manufactures rifles, and a lot of other machining manufacturers are moving to South Carolina. Thank you for listening, and if you have any further interest, please check out one of the videos that I have here on this page, or both of them. This will show you how our course operates here at Tech and give you some more information about machine tool.